All right, everybody, this is day 4 podcast, and if you will, look at your formula chart. You're going to see these two identities. Sine of 2 theta is equal to 2 times sine theta, cosine theta. In cosine 2 theta, you have a few options, 3 options. You have cosine squared minus sine squared. You have 2 cosine squared theta minus 1, and you have 1 minus 2 sine theta squared. Alright, so today we're just going to use these, and you might use tangent theta or the Pythagorean identity, but those I think you have down. So let's try some questions. Given sine theta is equal to 1 over 3, where theta is an acute angle, find the exact value of. So if you look at, that's a right triangle, and there's theta. Because sine of theta is opposite over hypotenuse, I can say that this side is 1 and the hypotenuse is 3. Now, because it's a right triangle, I can also figure out this unknown side. Okay, so let's call this x. So x squared plus 1 squared is equal to 3 squared. So x is square root of 9 minus 1, which is square root of 8. So instead of calling it x, I'm going to call it square root of 8. Or you can just say 2 square root of 2. Whatever you like. Alright, so A. What is cosine of theta? Well, cosine of theta is adjacent over hypotenuse, so I can say 2 root 2 over 3 or square root of 8 over 3. That really doesn't matter. I think if you can just leave it like this, just in case you can simplify. Alright, B, cosine of 2 theta, well, that's equal to 1 minus 2 sine squared theta, right? Using the rules that we just talked about. So 1 minus 2 times, what is sine of theta? That's 1 over 3, and you square that. So 1 minus 2 times 1 over 9, 1 minus 2 over 9, that's 9 over 9 minus 2 over 9, so it's 7 over 9. Okay, I need more room. I think I'm going to erase the triangle over here. Okay, sine of 2 theta, so C oh, 2 theta is equal to 2 times sine theta cosine theta. 2 times sine theta was 1 over 3, and the cosine theta is 2 square root of 2 over 3, so I get 4 square root of 2 over 9. Cool. Alright, number 2, if alpha is acute and cosine of 2 alpha is 3 over 4, find the value of cosine alpha and sine alpha. Alright, so we know cosine of 2 alpha is 3 over 4. Okay, that means I can say 2 cosine square alpha minus 1 is 3 over 4. So I'm using the identity to change cosine of 2 alpha into 2 cosine square alpha minus 1. Okay, so add 1 to both sides. So I get 2 cosine square alpha is equal to 7 over 4. Okay, and divide both sides by 2. So cosine square alpha is equal to 7 over 8. So cosine of alpha is square root of all of that. Okay, and you can simplify or rationalize the denominator, and what you get is, let's see, so that's the square of 7 over 2 root 2, multiply top and bottom by root 2, right, because that's 1, and you get square root of 14 over 4. Alright, now let's find sine alpha. Okay, so because cosine of 2 alpha is equal to 3 over 4. Using the identity, I can say, well, 1 minus 2 sine squared alpha is also 3 over 4 because these two expressions are identical. And I'm just going to do the opposite. Okay, 2 sine squared alpha is equal to 1 over 4. Okay, and then sine square alpha is equal to 1 over 8 by dividing both sides by 2. And so sine of alpha is equal to square root of 1 over 8. So 1 over square root of 8. I mean, you can put a square over there, but let's simplify. 1 over 2 root 2. And that's going to be square root of 2 over 4. Okay, so we found sine of alpha and cosine alpha, given that cosine 2 alpha is 3 over 4. Alright, given that sine of alpha is 3 over 4 and cosine of alpha is negative 4 over 5, find sine of 2 alpha and cosine of 2 alpha. So sine of 2 alpha, using the identity, is 2 times sine of alpha cosine of alpha. Okay, well, they gave you the two values, 3 over 5 and negative 4 over 5, and you get 2 times 3 is 6, times negative 4 is going to be negative 24. Negative 24 over 25. Alright, change the colors here. Alright, what about cosine of 2 alpha? Now this one you can pick any of the three identities that you have. I'm going to do 1 minus 2 sine squared alpha, okay, just because I can. And then I know this is 3 over 5. Sine of alpha is 3 over 5, so sine squared alpha is 3 over 5 squared, which is 1 minus 2 times 9 over 25. That's 1 minus 18 over 25. So 25 over 25, that's 1 minus 18 over 25 is equal to 7 over 25. So there is cosine of 2 theta. Alright, number 4, if sine of alpha is 5 over 3, where alpha is between pi over 2 and pi, so that means in the unit circle, that's pi over 2, and this is pi. So there is my triangle, and there's my alpha. Let me change the color of alpha. There's my alpha. So opposite is 5, and the hypotenuse is 13. Okay, so whatever value you see here in the cosine, you're just going to get a negative value. So using Pythagorean theorem, you can figure out that this is 12, but it's to the left of the y-axis, so it's negative 12. Okay, so I know, we know the sine of alpha is 5 over 13, and we know the cosine of alpha is going to be negative 12 over 13. Once you know these two values, you can figure out sine 2 alpha, cosine 2 alpha without a calculator, easy. So sine of 2 alpha is 2 times sine alpha cosine of alpha, which is equal to 2 times 5 over 13 times negative 12 over 13. That's equal to 60, negative 120. Negative 120 over 13 squared is 169. Okay, that's sine of 2 alpha. What about cosine of 2 alpha? Cosine of 2 alpha, you can use whatever value you want, but remember that sine of alpha was given to us, but not cosine of alpha we found. So just in case we made a mistake, we should probably only work with the value that was given in the question. And that's just my, what I think. If you're confident, you can do whatever you want. Right? 1 minus sine squared alpha. Okay, so I know that's equal to 1 minus 2 times 5 over 13 squared, and that's equal to 1 minus 2 times 25 over 169. That's 1 minus 50 over 169. So that's going to be 119 over 169. Okay, that's cosine of 2 alpha. Alright, let's scroll up here. Number 6. Skip number 5. Okay, number 5, if you factor out 2, you're going to get 2 times in the bracket 2 cosine square of 3 beta minus 1, and then you're going to use one of the identities to simplify. Your answer is 2 cosine of 6 beta. Okay, try that. If you have questions, let me know. All right, prove that sine x plus cosine x squared is equal to 1 plus sine of 2x. All right, so again, I'm just going to work with one side, and I choose to work with this side. So I'm going to do what? Sine x plus cosine x squared. What is that equal to? All right, that's sine squared x plus 2 times sine x cosine x plus cosine squared x. Okay, so if you move or change the second and the third term, and just get this. I haven't actually done anything yet. I just changed the order I'm adding. So here and here, I just switch them. All right, then you see from the Pythagorean identity, that's 1. Okay, and I'm just copying the rest of the cosine x. Okay, that's just a cosine, not a euro. Okay, there you go. So 2 sine x cosine x. Now, what is the second half? Well, that's equal to sine of 2x. Now, that's equal to what we're trying to show. And we have one last question to do, and we're done. Okay, obviously the left side is more complicated, so I'm going to work with the left side. And every time you see a double angle, just change it. Okay, so left side, and I'm going to work with the left side and make it equal to a tangent. All right, what do we have here? Let me just copy sine of 2x plus sine x over 1 plus cosine of 2x plus cosine x. Okay, I'm going to change this sine of 2x, and in the denominator I'm going to change cosine of 2x. Okay, so first, sine of 2x is 2 sine x cosine x and plus sine x over 1 plus. Okay, now I have to make a decision. I have 3 options, and I'm gonna have to change it, but there's 1 and there's a cosine x in the denominator, so I just want to keep it in all cosine. So that means I'm going to change it to 2 cosine square x plus 1, and then plus cosine x. Okay, from the numerator, I'm going to factor out a sine x. Okay, then I get 2 cosine x plus 1. Okay, denominator, here, let's see, that's going to be 2. Actually, this is actually really simple. The plus 1 here, and actually that should be a minus 1. Minus 1 right there. Okay, so what happens is just ones they cancel out. So all you have left is 2. Let me change it to blue. 2 cosine square x plus cosine x. So then you can just factor out a cosine. So sine x times 2 cosine x plus 1, and here you get cosine x and 2 cosine x plus 1. Oh, what do you see? Everything in the bracket is the same. They simplify to 1. All I have left is sine x over cosine x, but that is equal to tan x, which is what we're trying to show. Alright, that was day 4. Try the homework assignments, and if you have any questions, let me know.